one thing I want you to remember with word problems, infinity is very rare. Very rare. And that comes back to domain and range. Because remember, we had infinity with a range. It's going to stop with word problems, right? Okay. So when sketching the graph of a quadratic function, within a context, right? It's within a text. You must label the axes with words and units. It's very important that you don't just, right? You want words and units along the axes, right? That's not just time, but it's a time in seconds and minutes and hours. What is it? So both need to go on the axes, right? Start just like before. You find the vertex and the intercepts. That's the key to making a good graph, is your vertex and the intercepts. So we'll give you a good idea what scale to use when you're asked to graph. And let me tell you, I'll ask you to graph quite often to prepare you for next year. Because grade 12 applied has a lot of graphing too. Don't fear it. You'll be experts. Okay, you'll be like, oh, eyes closed. You'll just do it after a while because you'll have practiced it so much. So for example, if you have an equation given and you can tell there's no y and x, right? So this is already hinting towards a word problem. And where h of t represents the height in feet and t represents the time in seconds. Okay, so I will always tell you this. Whatever variables are here, always, we're never going to trick you on that, goes along the x-axis. We're not going to trick you on that. And whatever is over here, that's what goes on your y-axis. So that's something important to remember. Whatever variable, whatever goes there. So that means that if t is over here, time, right? We're going to write that down here on the x-axis. Time, and it says in seconds. So we go with time in seconds. And then over here, the ht represents the height in feet. So somewhere along the y-axis, you go height, feet, and so that's very important to us in this unit. When it comes to the domain and range, is there anything? Oh yeah, I need to explain a bit more here. When you're given an equation like this, we know that from now on, because of this description, everything is time. The first number represents time, the x value, and the y value represents the height. So a point isn't just a random point anymore. It actually tells you what the time was at that certain height. Okay. It used to be xy. Now we're going to go time and height. So keep that in mind. This is the vertex here. No surprises, but it means something to us. So that would be xy, right? It tells us, so we'll go arrow, gives the maximum height after x seconds. And trust me, they're going to ask for that quite often. Like, what's the highest height, or what's the maximum height that this athlete was able to jump, or this projectile was thrown at, or whatever. It's the maximum height. You know it's the vertex. This one over here is what we call the y-intercept, but it's known as the initial height. Initial height at time equal to 0. Okay, so this is always going to be 0 followed by a number. If it's in general form, it'd be 0c, right? Whatever that last value is, it's the same thing. Okay. This over here is what we call the x-intercept. extent, I will go out, the explanation will go down here. In this case, it would be time the object remains airborne. Okay. Hits the ground. It could be hits the surface of the water. If someone, jumps off a cliff into the water, then it would be that touches the surface of the water, but the same idea is still there. So that's my x-intercept. Anything else? Oh yeah, this would be a number 0, right? That would be a number, whatever it is. You're going to find the x-intercept. You find that, right? What's missing here? On your graph, okay, on your calculator, the calculator doesn't know this is a word problem. It would probably continue here, right? The parabola would continue here on the left side. We would not want to include that in this case because time cannot be negative, right? So this is why this x-intercept out here is not included. So that's another nuance about word problems. So just an intro here. Let's talk about domain and range, how that would change. So I'm kind of just making the relationship between y-intercept, vertex, and x-intercept to real-life situations. That's all I've done here. And so you'll see how that comes to play later on. For domain and range, domain talks about all the x values. Range talks about all the y values that are that fulfill or are still part of the graph. And you've got your different choices here, set notation, interval notation. For set notation, you would go domain like this. Generally speaking, it'd be 0 from 0. And in this case, it's time, right? To highest x value. Highest, I'm not going to use highest because then you're going to think of height. Sorry about that, guys. Greatest x value. How's that? Greatest x. That's what I'm going to put down there. And for my range, if we stick with set notation for the range, it will be lowest y less than or equal to. In this case, we have h as our variable, right? The y of the vertex. Okay. Interval notation for both of these would be, for domain, we would go from 0 to greatest x, square brackets, because if you have numbers for both of them, it's going to be square brackets. And for my range, it would be lowest y to you know what? I think I will make another change. I hope you use pencil. I'm just thinking of common mistakes that I've seen. And this is generally going to work. But can I go greatest y here? I know you're not going to like me. It hasn't changed. Anyways, greatest, change this to greatest y. Lowest y to greatest y. And this would be lowest y to greatest y, like this. Because I know what, I'm now thinking back when I do vertex, students think it's always the vertex on that side, and there are instances where it's not. That's why I'm making that change. And right now this is gibberish to you, but we're going to apply this to specific examples on the back side of this. I have lots of examples there. So we're going to apply that. Hold on. I know I'm taking my time because I want you to be experts at domain and range. This is for word problems, okay? That's very important. This is not for one that I just give you. I just give an equation. You still do the x belongs to all real numbers, and then right, it goes to either positive infinity or negative infinity for the range. So infinity symbol is rare, okay? In grade 12 applied, you're gonna see a little bit more of the infinities because it comes to population growth and stuff like that. Technically, we don't know when it's gonna stop, right? So for bacteria or money or whatever, if you invest it, it just keeps on growing. But in this course, infinity is very rare. Keep that in mind. So now we're going to practice this. We're going to practice writing this out, okay? So let's go to page 33. And I'm going to use two different colors, two different highlighters for my domain and range, okay? I used this in IPR and it worked pretty good when I used this method, okay? I'm going to use, if I ask you domain and range, right? This is my domain and this is my range. I'm going to use interval notation first, and then I'm going to go set next. That's kind of, I feel like interval is easier to wrap your head around. Okay. So for the domain, I'm going to use pink. Okay. And so basically what you do is you look at the graph. Where does it exist? If you were to travel along the x-axis and keep looking up, graph is still there, graph is still there, and then it stops after this. So it essentially spans from here to here, okay? And you can feel free, if you go to your graph here, it starts at 0 here, goes all the way to 450. Because we know that that's the point here. So in terms of my x values, it goes from 0 to 450. So remember, always the lowest first. So you go 0 to 450. Boom, you're done. You don't need variables in there. You just need numbers. That's my preferred way of stating my domain and range is interval. Then we're going to use, I'm using green, but you can use whatever you want for this one, right? So for range, we're looking, I basically travel along the y-axis, by the way, and I look to left or right to see if there's a graph. So if you start here, you see a graph, and then once you get to the vertex, that's the highest point. Past that, you no longer see a graph. So I kind of just make like a dashed line going to here. So I know that the graph exists in that range. Those are, wherever the green is, those are the acceptable y values. And again, you start at 0 and you go all the way up to, I'm focusing on the y values, right? So this would be what? 50,000? This is the 50,000 mark. Can you see that there? That's the 50,000 mark right there. So I go from 0 to 50,000. So the lowest possible value here is 0, and the highest y value acceptable here is 50,000. Notice that the 225 doesn't come into play here anywhere, because I'm only worried about the lowest x value, the highest, the lowest y value, the greatest y value, and here it is. Now let's translate this to set notation. It's a little bit more, you got to be careful, let's put it that way. So you use squiggly brackets. You're going to put 0 first and one of these. Okay. And then whatever variable, let's say the variable is lowercase l. Okay. And over here for the y, the variable is a. Because the equation would have had to give you that, by the way. I'm just making it up right now, but L and A are our variables. So right now I'm talking about the L variable, which is along the x-axis. And so this has to be less than or equal to 450. So the numbers still follow you. And then you have the variable in between. And these are always facing the same way. Okay, so you gotta make sure you understand that. So L is less than 450, less than or equal to, but it's greater than 0. Okay, so if you look at L, that's how it is. R, 0, less than or equal to, and then variable A, and then 50,000. That's how you state your range using set notation. Okay. So I don't know if you want to break this up, make a bit of a table like that. Okay. You try that. I want you to try just the interval notation, not the set notation, with this one. So you have a domain. Maybe don't highlight just yet. I'll do that with you. But for both of them, what do you think would be your domain and range? Let's try the next two here. What would be the domain and range here? What would be the domain and range there? And if you're comfortable, you keep going, right? But make sure you use a pencil, don't use a pen. Kind of using the same idea that I just applied there. For applied math, the best analogy I have for you is if you were to set your x min and x max, y min and y max to whatever you just came up, you would have a perfect window where your graph would fit into. Think of it that way, right? If you were to go x min, x max, y min, y max, that graph would just perfectly fit into your window. That's basically what you're coming up with. But if you're in pre-cal, you would have no idea, right? What is that? What are you talking about? Window, right? But there it is. So for your domain, 0 to 17. Yes. For my range, oh, I should probably do the highlighting, right? At least for a couple more. So from 0 to 17, that's our domain. And then from 0 all the way to, this is the highest point right there. So the 15 is kind of not necessary, right? It's not going to make a difference for your domain and range. You've got 0 to 17. So even if you write out these numbers, it will help you, right? So 0 to 18 is my range for this graph. I was very pleased with this one for the most part, right? So your lowest x value is 0, it touches the y-axis, and the highest is 10. Yeah, so I'm going to highlight that part. So you go from 0 here all the way to 10. And for the range, you go as low as -20 and as high as +3. Okay, so you go from here all the way to here. Okay. So -20 all the way to +3. So that's what determines my range. And then for this one, maybe a little tricky as well. But my domain still goes, and that's quite often the case, that it starts at 0 for the domain, and then it ends at 4.5 here. Okay, so you go, and in this case, you're not touching the x-axis, so you kind of have to just look at the point there. But this gets you to 4.5, and you start at 0, right? And for the range, you go from, so this is, you have to be careful, as low as 13, okay, all the way to 32. So this is where the range happens. So this would be 13, and this would be 32. Lowest first, okay, greatest second. That's always the rule. If you remember that, have them in the right order. That's also important to us. Square brackets for these ones, no squiggly brackets, okay, if you want full marks, if that's what you're interested in. Let's translate all of these to set notation. So I'm just going to go like this, 0. What do we have? We have time and height, right? So we're going to go, the x is time and height like this. Okay, translate this one. This one would be time still, so 0, time, 10. And the range would be, negative 20. And we've got height still on the y-axis, so that's pretty safe there. Like that. And then for this one, we have time and height again. So we'll just stick with time and height for now. This will be 13. Oops, sorry, I made a mistake. I know, I'll fix it. I'll fix it. I was mixing up interval and set, right, in that one. Oh, I made another mistake. Hey, we're on a roll here. You see it? This is not supposed to be t. This is supposed to be whatever is on the y-axis, right? Whatever letter they use for the y-axis is what we put in there. Not always t and h. It depends on the scenario. Depends on the scenario. All right. One more on that on page 34. Can you do that one? Both interval and set all by yourselves. Pretend like this is an AC first thing tomorrow. Can you do it? I think you can. Domain and range can easily, like, it's usually a mark each, 1 mark for each. If you need to use your calculator to find some points, then it's worth 3 marks probably in total for the domain and range. So keep in mind that down the road, we are going to find these points that are on the graph. Okay, that's going to be our job to find them. So sometimes these are pointing up, sometimes they're pointing down, so watch out for that. Here are the answers if you need to compare. So your homework is going to be just making sure you have something on your study sheet that helps you very creatively come up with the domain and range. Make it so that when you pick it up in June, you can look at it and be like, oh yeah, I got it, right? That's what you want to design. If you want to look at what I have on 32 to help you out at the bottom of 32, then you do that, right? Have something that helps you out, emphasizes the square brackets versus the squiggly, all those things, those little details come into play, okay? When I mark the exam, a lot of marks are lost when it comes to those little details, like forgetting the squiggly versus squared brackets and things like that. This one, I'm just gonna talk about on 34. I'm almost done. You can basically just pay attention if you want. You don't have to write this down today if you don't want to, but I want to talk about it. If b is equal to 0, so if this one is equal to 0, folks, so you have something that looks like this, your graph, right, the vertex will be the same as your y-intercept. And that's something you need to watch out for. It's not that like your calculator will help you out, but sometimes students find the vertex and then find the y-intercept and they get the same answer and they're like, Mr. Dirksen, my calculator isn't working, right? No, it's not the calculator, it's a fact, right? If b is not equal to 0, right, you've got the vertex here and the y-intercept is over here. They're different. So the vertex is not equal to the y-intercept. Just a little, side note. That's the main difference. If b is 0, then this is your scenario. Okay, that's all I want you to remember. Have a good